Hi guys, I'm here to present for the seminar that is happening on the 12th of April, and I will present my topic that will become the thesis, my thesis, and the name is An Eye into the Future, Leveraging a Priori Knowledge and Predictive Business Process Monitoring. And I'm working closely with Fabrizio Maria Maggi and also Chiara Francesca Di Marino from Trento. And yeah, let's start. First, I will give some very basic introduction what is business process management and all the field that I'm working in is about, and also then I will delve into the what is happening in the field right now and my solutions and results and future works possible. So BPM is business process management, and you should already know because the courses are extensively taught in our department by Marlon Dumas and Fabrizio Maggi. So let's go deeper. That is process mining. It's a part of that field, and it analyzes business processes that are in the form of logs that are recorded, pre-recorded in database from business process executions in any companies. So, and I'm concerned with predictive monitoring, that is using those logs into online prediction and online checking or any of this kind. For example, that you want to know if the process will end with some deviation, or if the deadline will be met, or you just want to know the sequence of next activities. So my research question is basically, how can a priori knowledge, the knowledge that's already given to us, that we know about the future, be used in order to provide accurate predictions for future executions of an ongoing case? And I also outlined two sub-research questions that are, how do we represent a priori knowledge, and what's the best predictive model to be used? Let's go deeper. So let's start from the simple. What is ongoing case? Ongoing case is actually some trace, some business process or any process that consists of activities, and also data values or payload that is associated with each activity, such as an activity can be, for example, as on the slide, where the person is, and the payload is what is the temperature, that is normal high, extra high, or deadly low, or timestamps. And then what is the future executions? Future execution is just basically what will be the next steps that we don't know yet online. And what is a priori knowledge? A priori knowledge, in our case, is the knowledge that we can already know before the case is executed. And one of the motivation for this are, for example, that we know that, let's assume that tomorrow in the hospital the doctor 1 is not available. It's just not available. It cannot happen that he will take some patients. So we know that the doctor 2 will take care of patients. Or, for example, that surgery cannot happen without screening. That means that whatever we do tomorrow, day after tomorrow, but if we do surgery, that means that we should have done screening beforehand. So that's also a very important step. So we actually try to somehow use this a priori knowledge in helping us to predict better. So how do we represent a priori knowledge? It's we chose LTL rules, that is linear temporal logic rules, that will allow us to express most of the concepts that are needed. For example, that treatment A and treatment B cannot be both used within the same course of cure, or as I told before, example, that screening should be prerequisite for the surgery, or something cannot happen. And what is accurate predictions? We evaluate our algorithm by Damerau-Levenshtein similarity. That is actually normalized Damerau-Levenshtein distance. That is this distance is calculated as number of different operations needed to transform one string into another. So it came from string theory, not string theory, but the NLP and the tasks for strings, comparison of strings. But we adapted, and we have similarity between two processes, and it is normalized, so it's between 0 and 1, and it shows it works best with processes. Also, what's the best predictive model to be used? There now we talk about the state of art, and I'll start by a paper by Anna Leontieva that went out in 2015, and it was initially about prediction of true or false classification, and they just used complex symbolic encoding and random forest classifier. And then they also extended their model and added some HMM encoding, but the computations are usually very expensive, and they are not very accurate. Then Irene, they added even more to that. They added some information from payload, adding some textual data by encoding it by paragraph vector, back of n-grams or naive Bayes log count ratios. And they also used random forest classifier, and also they tried to use support vector machine classifier, but it's proved to be not the best working prototype. Then Polato, they tried to build transition system for entire log. Then they cluster new trace with respect to the legacy log, and annotate the piece of transition system that is used for those similar prefixes, and then just predict the shortest path. The idea is good, but it doesn't work quite well in practice. Then the last idea, and the best that we chose actually, is to use long short-term memory, a deep neural net, and it's very good approach, because, and actually it is this approach is a state of the art in many problems, such as NLP problems or sequence to sequence predictions. And Ilya Verenic and Niektax, they tried to use it, and they gave very impressive results in comparison to those mentioned previously. So we decided to use these for our algorithm. Then what is be used in order to provide? Now I will tell you how actually we do it. How do we imply the a priori knowledge into our LSTM model? So there are two steps. First is to use LSTM to learn from the past. So we use the proposed by Nick model. We used to learn from the logs, and then we change standard inference algorithm to produce compliant with LTL formula predictions. That is done by incorporating beam search into inference algorithm, and next slide will show how it's actually done. This is the pseudocode for that. It's quite complex, but I will highlight the main points. The main stuff is that when we try to predict next symbol, we actually predict more than one symbol, but we predict some B-size symbols, and then for each of those we predict also B-size of the symbols. But as we need to keep the stack, we need to allow we need not to overflow our memory. So we have this top ranking function that will actually choose only best candidates, and our algorithm will give us the results when both conditions are satisfied. That is, that the candidate is the last symbol is found and end symbol, and also the trace is compliant. So after building this algorithm, we tried to test it on many different logs, such as these on the picture, and you can see that they are very different. For example, first one, and environment log permit, it has only 900 traces. It's very sparse, especially it has 300 activities, so almost all traces are not repeating. And in comparison, for example, BPI 12, it has a lot of traces and only 7 activities, so it was quite easier to work with that. And we also chose LTL formulas such as those shown on the picture, and those are mostly, for example, weak are that existence, like for example A exists and C exists, and a priori strong is existence with implication that is that A exists and also from A should follow B. And the results are displayed on this graph. You can see that for most logs it gives much better results, and that can prove that our approach is quite successful if you actually know the a priori knowledge. So yes, for the discussion part, a priori knowledge does help to make more accurate predictions, but yes, always we can find many problems with those. For example, we could have actually missed, and we could in theory make some better algorithms. So that's the second one. And first is that we can try to use better models for predictions, because in this case we just took the baseline approach for Ilya and Nick paper, and we chose their neural network based on LSTM, and it's quite simple. They only have few layers and of standard LSTM, and I think that probably if you use some better encoding, it could help even better. And also they didn't use embeddings, it could help. And yep, and please do not hesitate. Sorry by the way, sorry that I do not attend now, because I cannot be right now in Tartu, but do not hesitate, ask me a question. I will answer in the best possible form, in written form. I will answer to all your questions. Thank you.